In this video, we're going to take a look at simplifying and multiplying rational expressions. So steps for simplifying and multiplying rational expressions are that we want to factor out the numerator and denominator. We want to cancel common factors on the top and the bottom, only one for one, so you can't cancel out if you have an odd number of them. And then write out the expression in simplified form and state the restricted values on the variable. So restricted values are values that make the denominator equal to 0. So let's write that out. Values of the variable that make the denominator, any denominator in our problem, equal to 0. Okay, so let's take a look at 4 examples of simplifying and 4 examples of multiplying. So for my first example, I have 7x divided by 14x squared plus 49x. So we want to work on factoring everything out that we can. So 7x is just one term, so we just bring that over. You can't do anything more with that. And then in the denominator, we could take out a 7x, and then we would have 2x plus 7 left over. So then we can reduce that because 7x and 7x would cancel out. And so since those cancel out, those are common factors in our numerator and denominator. Leave a 1 since nothing else is left in the numerator, and then 2x plus 7 is our denominator. We want to state restricted values, so you take that denominator and you can set it equal to 0. So if 2x plus 7 equals 0, and solve for x to figure out what that would be. So I can subtract 7, I can divide by 2. So I would say x cannot equal negative 7 halves because that would make my denominator equal to 0. So my final answer is the simplified form of my expression and the restricted value on the variable. All right, let's look at another example. For example 2, I have negative 3x plus 6 divided by x squared minus 6x plus 8. So first I want to take out a negative 3 and leave x minus 2 left over. And in the denominator, I want to factor the trinomial. So it's just a basic trinomial. I need to multiply to get 8 and add up to negative 6. So that'll be x minus 2, x minus 4. And then we have factors in the numerator and denominator that they match or they have in common. So we're able to cancel those out and then bring over what's left. So we have negative 3 over x minus 4. That's part of our answer because that's the simplified form of our rational expression. But then set the denominator equal to 0 and figure out what value of x would make that denominator equal 0, and it would be 4. So we say x cannot equal 4. All right, let's look at one down here. We have x squared minus 64 divided by x plus 8. So in my numerator, I have a difference of 2 squares. So I factor into x minus 8, x plus 8. The denominator is just x plus 8, so we can't factor that any further. And then notice those two are in common in my numerator and my denominator, so I can cancel them out. And then I just have x minus 8 left in the numerator. So then you still want to say x plus 8 was my denominator. Where would that equal 0? And so subtract 8 and you solve it and you get, well, x would equal negative 8, so x can't equal negative 8. So that's my restricted value. Notice negative 8 plus 8 would equal 0. So you're just checking for what values of your variable would make your denominator equal to 0. And the restricted values are those. All right, number 4. We just have to factor out the numerator, which is a basic trinomial. So we figure out what will multiply to give us negative 2 and add up to negative 1. So it'll be x minus 2, x plus 1. Same thing for the denominator. We got to multiply to get 6 and add to negative 5. So x minus 2, x minus 3 would help us to do that. And then we notice we have a common factor in the numerator and the denominator, so they cancel out. And then you have your simplified rational expression of x plus 1 divided by x minus 3. And so that's part of your answer, but you just got to say x cannot equal what would make these factors in my denominator equal 0. So x cannot equal 2 and x cannot equal 3. So your answer needs to be a simplified rational expression and the stated restrictions on your variable. So we're done with simplify. Let's take a look at some examples of multiplying. Simplify and multiply are very similar to one another because they have the same steps basically. You just have more than one fraction that's being multiplied together. So for number 1, we have 3x squared times 4y. So what I like to do is go ahead and put that together in the numerator. So I get 12x squared y over 2 times 10, which is 20, and then x cubed y. That usually helps just put them together and then you can simplify. It's not the only way to do this problem. It's just one way to think about it. Then if I think of 12 over 20, so 12 divided by 20, they both divide evenly by 4. So 12 divided by 4 would leave me with 3, and 20 divided by 4 would leave me with 5. Then I have x squared and x cubed. So x squared and x cubed would reduce and leave me with 1x in my denominator. And then I have y on the top and y on the bottom, so they would cancel out. So what's left on top is just 3, and what's left on the bottom is 5x. So that's my simplified rational expression. Now over here, y cannot equal 0 because 2 times 0 would equal 0 for that denominator, and x cannot equal 0 either. And it's because 2 times 0 would equal 0, and that's not possible. And then 10 times 0 cubed is like 10 times 0, and that can't happen either. So you just have to state that both of those variables cannot equal 0. All right, let's look at another one. Number 2 has 3x plus 15 over 2x plus 8 times 3x plus 6 over 2x plus 10. So let's start factoring. These look like we could take out a 3 for our greatest common factor in that first numerator. So I would have x plus 5 left over. If I take out a 2 from the 2x plus 8, I have x plus 4 left over. If I take out a 3 from 3x plus 6, I have x plus 2 left over. And if I take out a 2 from 2x plus 10, I have x plus 5 left over. So then I have x plus 5 in my numerator and x plus 5 in the denominator. So even though they're in separate fractions, they can be reduced or canceled out. As long as one is in the top and one is in the bottom, or one is in your numerator, one is in your denominator. And then we have 3 times 3 in my numerator, which would be 9, times x plus 2, over 2 times 2, which is 4, and then x plus 4 is left over. And so that is my simplified rational expression. But I still need to focus on what would make my denominators equal to 0. So I would say if x was negative 4 plus 4 would equal 0. So x cannot equal negative 4. And then over here, if I said negative 5 plus 5, that would equal 0. So x cannot equal negative 5 either. So those are my restricted values of the variable. They would make my denominator equal to 0, which we can never do. We can never divide by 0. So that's why we're always checking for those. All right, so for example 3, looks like we have some difference of 2 squares involved. So in my numerator, I'm going to factor x squared minus 4 into x plus 2x minus 2. In the denominator, I'm going to factor that into x plus 1, x minus 1, because it's also a difference of squares. And then I just have x plus 1 in my second numerator. And if I take out an x in the denominator as my greatest common factor, I've got x plus 2 left over. So then we look for common factors. So I've got x plus 2 in the numerator and another x plus 2 in the denominator. We also have x plus 1 in the numerator and the denominator. So those can all cancel out. And then we bring over what's left. So we have x minus 2 in the numerator. And we have x times x minus 1 in the denominator. And I would just leave it like that. You don't have to distribute the x. And then let's figure out what was in my denominator that would make it equal to 0. So I had x plus 1. So x cannot equal negative 1. I have x minus 1. So x cannot equal positive 1. And then I have x. So x can't be 0. And I have x plus 2. So x cannot equal negative 2. It's like the opposites of what you have. And it's because negative 1 plus 1 would equal 0. 1 minus 1 would equal 0. A 0 right out front would make that denominator equal to 0. And negative 2 plus 2 would equal 0. So sometimes you do have multiple values that are restricted. And that's okay. All right, for our last example, number 4. Looks like we have a mixture of factoring to do. So we have a trinomial to start with in our numerator. We need to multiply to get negative 2 and add to get the 1 that's in the middle. So that would be x plus 2, x minus 1. The x minus 5 in the denominator would just stay there because we can't do anything more with that at the moment. Then we have a difference of 2 squares in our numerator of our second fraction. So let's factor that into x plus 5, x minus 5. And then in the denominator, we have another basic trinomial. So we need to multiply to get 2 and add to get negative 3. So we need x minus 1 and x minus 2. And then we look for our common factors. So we've got x minus 5 is in the numerator and the denominator. And we have x minus 1 is also in the numerator and the denominator. And then you just bring over what is left over. So what did not match was x plus 2, x plus 5. Those are both still in my numerator. And then x minus 2 is still in the denominator. So that's my simplified rational expression. And then x cannot equal any value of the variable that would make this denominator equal to 0. So because 5 minus 5 would equal 0, x cannot equal 5. And then 1 minus 1 would equal 0, so x cannot equal 1. And 2 minus 2 would equal 0, so x cannot equal 2. And that's it. So that's your notes on simplifying and multiplying rational.